Imagine waking up tomorrow to find every cell tower, fiber optic cable, and Wi-Fi router on Earth has gone completely dead. The grid goes dark. If you had to navigate across your home city to check on a relative, could you map the route entirely in your head? Try to recall the phone numbers of your closest family members using only the data stored in your internal biological memory. A century ago, this type of internal mapping and rote memorization was a baseline requirement for moving through society. People biologically retained vast directories of spatial and factual data as a matter of survival. We treat the internet like a reference library we can casually visit, but it has become a load-bearing pillar of our daily cognition. Strip that pillar away, and you expose a severe biological vulnerability we've been quietly developing for decades. When researchers began standardizing mass intelligence testing in the early 20th century, they noticed a consistent, measurable trend. Throughout the 1900s, human cognitive capacity consistently tracked upward, a phenomenon named the Flynn Effect. But for cohorts born after the 1970s, this long climb has stopped. In industrialized nations, scores tied to verbal skills and structured reasoning are actively dropping. Neurologists track this decline directly alongside the saturation of digital technology. Because the human brain is highly neuroplastic, it physically reshapes its cortical architecture based on the demands of its environment. Reliance on external digital networks carries a steep physical cost. It actively rewires the biological structures of the brain. To understand how this rewiring started, we have to look back at the early adoption of desktop computers in classrooms and libraries. As search engines became ubiquitous, psychologists identified the Google effect. We began treating the internet as a transactive memory partner, adapting our brains to prioritize remembering exactly where to find a piece of information, rather than encoding the factual information itself. This created a metacognitive bias known as the click illusion. Because we can retrieve answers instantly, we mistakenly equate the vastness of the internet's external database with our own internal intelligence. Longitudinal brain imaging studies show the physical toll of this illusion. Frequent, heavy reliance on digital search correlates with reduced gray and white matter volume in the parasylvian areas and prefrontal cortex, the exact regions responsible for language processing and executive control. Placed in an environment of absolute information abundance, the human brain ruthlessly conserves its biological energy by erasing its own internal hard drive. Humans have successfully offloaded rigid, procedural tasks to machines for a long time. We outsourced complex arithmetic to scientific calculators while maintaining our capacity for critical thought. Generative AI represents a massive escalation of this dynamic. These models directly perform integrative reasoning, the complex work of synthesis and evaluation once reserved for the human mind. This introduces the sovereignty trap. When faced with a complex, ambiguous problem, human motivation naturally seeks the path of least cognitive resistance. Falling into that trap creates a state researchers call the hollow in mind. When you bypass the deep biological struggle of puzzling through an argument, your critical thinking musculature atrophies from disuse. By letting an algorithm do the heavy lifting of intellectual synthesis, we trade our capacity for independent judgment for the immediate gratification of a generated answer. That biological trade-off accelerated once the internet moved off our desks and into our pockets, establishing a permanent physical connection to the network. Some cognitive scientists look at this same data and propose an alternative. This transition might represent a successful adaptation to a new environment, rather than a biological breakdown. This is the extended mind thesis. It argues that the human mind does not stop at the skull. Instead, it forms a deeply coupled cognitive system with the external devices we use every day. Standard IQ tests were designed for industrial-age sorting, measuring clerical skills and isolated pattern recognition. But in an economy where the relevant unit of analysis is the human plus AI system, these isolated metrics lose their predictive power. If intelligence is measured by what the coupled system can accomplish, the 20th century exam is effectively an artifact. From this systemic perspective, humanity is upgrading into a massive, distributed superorganism. We operate in an ecosystem defined by the absolute, infinite availability of digital data, colliding daily with the fragile, finite limits of human attention. When a machine can retrieve any fact or write a functional essay in seconds, sheer biological memorization is no longer the hallmark of human intelligence. True modern intelligence is cognitive sovereignty, the specific wisdom required to know exactly when to leverage an artificial system to scale a massive problem and when to purposefully disconnect. Our greatest remaining intellectual asset is the discipline to sit in the quiet, endure the friction of deep reflection,